This video is hypothesis testing with one sample, null and alternative hypotheses. If a car manufacturer claims that one of their models averages more than 38 miles per gallon on the highway, how can we verify this claim? There has to be a way for us to see if they're telling the truth or not. So the process that we would use is called hypothesis testing. It's where a claim is made and we test it. Now, hypothesis testing is very similar to what we've done with confidence intervals, but with hypothesis testing, it's a way of clearly laying out the evidence that confirms or contradicts a claim like the gas mileage one. So to perform a hypothesis test, what we're going to do is we're going to describe two contradictory hypotheses. So think of a criminal trial. So the defendant is either guilty or not guilty. So we will have two contradictory hypotheses like that, and then we're going to collect evidence. And then based off of that evidence, we're going to make a decision in favor of one or the other. Here is an example of cereal box weight. We've actually seen this particular example before in previous videos, in previous sections. But let's review what it's about. A machine that fills cereal boxes is supposed to put 20 ounces of cereal in each box. A simple random sample of 6 boxes is found to contain a sample mean of 20.25 ounces of cereal. It is known from past experience that fill weights are normally distributed with a standard deviation of 0.2 ounces. Construct a 92% confidence interval for the mean fill weight. Now, we did this back when we studied confidence intervals, and when we saw that it said that from past experiences it was known that the standard deviation is 0.2 ounces, that told us that that was a population standard deviation, and since we were looking for the mean, we used the formula for a z-interval, or we used the calculator for a z-interval. And we found that the mean weight of the cereal was between 20.12 ounces and 20.38, and we concluded that the weight was over 20 ounces. They were overfilling the boxes of cereal more than the 20 ounces that it was supposed to be filling it, because the entire interval was above 20. So let's pretend for a moment that instead of getting the confidence interval that we got on the previous slide, we got this confidence interval, and we estimated that the mean cereal weight in the boxes was somewhere between 19.88 and 20.56. This interval does include 20, and if we had gotten that, we would not have been able to conclude that the average weight was more than 20 or less than 20. Over here, we were able to conclude that it was more than 20. But here, you can't conclude that. You cannot conclude that it's more than 20 or less than 20. Now, we wouldn't say that the average weight equaled 20. Okay, we are not allowed to say that. We're not allowed to say inequality, that it equals 20. All that we've shown is that we haven't found the evidence that it's greater or smaller than 20 ounces. So this is where you kind of think about a trial, a criminal trial. In a criminal trial, a jury makes the decision if the defendant is guilty or not guilty. They never say that the defendant is innocent. They use the words not guilty. It's going to be the same kind of thing here. So we can't express that an equality statement is true, such as the average weight equals 20. But more on that a little later. So if we did a hypothesis test with the cereal example, we'd find with 92% confidence the same conclusion. But a hypothesis test is a different way to go about it. But the hypothesis test and the confidence interval will draw the same conclusions. It's just, instead of going through the front door, we're coming through the back door. It's just a different way to go about it, but to get to the same place. So there are different types of hypothesis tests. We will be talking about many of them in these last chapters of statistics. One type of test that we use will test a claim about a population mean. when the population standard deviation is given. That's kind of like when we were estimating mean for confidence intervals and they gave us the population standard deviation. We did a z-interval. Well, in this case, you would do something called a z-test. Then there's a claim that we can test for a population mean, but in that case, we won't know the population standard deviation. So that's very similar to the confidence intervals we found when we didn't know the population standard deviation, but we knew the sample standard deviation instead, and we did a t-interval. So in that case, we would do a t-test. Then there's a claim about the population proportion. In that case, that's very similar to our 1 prop z interval. In this case, we would do a 1 prop z test. Now, the first three we will be discussing in this chapter. In future chapters, we're going to test the claim about the difference between the means of two different populations. And we'll also test the claim about the difference between proportions in two populations. And then we'll also do a test for independence to see if two variables are independent or dependent. But in general, a hypothesis test tests a claim about a population parameter based on a sample. Remember, a parameter is a number that describes the population. So if you look up here, in all of these, we're either testing the population mean or the top population proportion. Both of those would be parameters. So let's talk about hypotheses. So you will need to make two hypothesis statements. And what I'm going to do is I'm going to make references to criminal trials because hypothesis testing is much like that in process. So at the beginning of a trial, there's the defense and there is the prosecution. So the defense makes their opening statements and they say whether they believe they're innocent or guilty, and usually they think they're innocent or they say they're innocent, and then the prosecution makes a claim that they are guilty and what crime they believe they are guilty of. So we have two types of hypothesis statements. We have a null hypothesis and an alternate hypothesis. For the null hypothesis, think of the defendant in a criminal case. This is in a criminal case, this is the person being accused of a crime and they are proclaiming their innocence. That's what our null hypothesis is. This is a parameter that is claiming its innocence. It's claiming that it is equal to a specific number. In the cereal box case, it would be claiming that the mean of the cereal box weight is equal to 20. Now, a null hypothesis is always an equality statement. It always has an equal sign, okay? At least in these beginning ones that we're going to be doing. So always equals, always equals. So you might have something like for the null statement, you might say the mean is equal to 20. And that would be what the defendant proclaims. The defendant is proclaiming that they're innocent. They're proclaiming that the mean is equal to 20. Well, then, on the other side of the room, we have the prosecution. The prosecution. The prosecution is who is stating that the defendant is guilty. And they're trying to tell the court what they're guilty of. So for our prosecution, we have what is called the alternate hypothesis. And they're going to say that the mean is not equal to 20. So the statement here is not, it's not an equality. It's not going to have an equal sign in it. So the other thing that I need to show you here is the notation. For each null hypothesis, we use H And it's actually supposed to be a subscript 0, like this, like that. And then for the alternate statement, we have H with a subscript 1 or H with a subscript A, like that. And that's the notation for each one. So again, null hypothesis is an equality statement. It is what is on trial, basically. So what we would do with the cereal boxes is the manufacturer claimed that it's supposed to fill the cereal boxes to 20 ounces. So that is the defendant. This is who is being accused. It's accused of not being 20. So its innocence would be that it actually equals 20, and its guilt would actually be that it's not equal to 20. So we're going to make these beginning statements. So think of the opening statements of the defense and the prosecution. And then we're going to collect some evidence and we're going to analyze it, and then we're going to come back and we're going to make a decision. We're going to make a conclusion, such as what the jury has to do. So the jury comes back with the decision to say that the defendant is either guilty or not guilty. Now, we're not going to say guilty or not guilty for a hypothesis test. Instead, we're going to say the equivalent for us. We're going to say reject the null, reject HO, reject the null, or fail to reject the null. Rejecting the null means we're saying the null isn't true. We've got enough evidence to show that this null is false. That would be the same as saying that the defendant is guilty. Or we're going to fail to reject the null. And if we fail to reject the null, that does not mean that the null is true. All it means is that we didn't have enough evidence to say that it was not true. So we will never say that we accept the null. We will never say we accept the null or that the null is definitely true. We can only say that the null is not true, or that it's guilty, that we reject it, or we can say we fail to reject it. And that's all you can say. You can't say that it's innocent in the closing decision. So let's talk about how to write the null and the alternate hypothesis. The null hypothesis is always an equality statement. It's always going to have an equal sign. So you start by writing H subscript O. Then you decide, am I defending a mean or a proportion? Which parameter are we talking about? So then we'll say that the mean equals a number or the proportion equals a number. So in the case of the cereal box, we would say the mean equals 20. For the alternate statement, we write H subscript 1 or H subscript A with the same parameter notation, in this case mu. And then we state what we believe or what the claim is. So looking at the evidence, it looked like the cereal weight was over 20 ounces. Now you have three choices. You can say that you believe the mean is less than 20, that is greater than 20, or it's not equal to 20. We could have used either the greater than 20 or the not equal to 20 for that particular question based on the evidence. You would do the same thing if it was proportion. You would just use P instead. Okay, so before we go into examples, I'm going to stop this video and we will pick up with example 2 in part 1. I'm sorry, in part 2.